So if f of x is equal to the absolute value of x between negative pi and pi. Now let's think about that function before we do anything. So if we have our graph in the xy plane, well, we know positive x, that's easy, right? That's y equals x. Now absolute value tells us that instead of going down here, it's going to go like this. Well, that looks symmetric about the y-axis. So I would say that that's an even function. So we're going to call this even. So we're going to use the Fourier series that goes with even functions. So it's going to mean a couple of things for us. One thing it's going to mean is that if we have an even times an odd, so we have that whole thing where we're negative and positive over an odd, so this whole term is going to be 0. So I'm just going to declare right now b of n equals 0, just from identifying what type of function this is. So we've already saved ourselves 25% of the work. Okay? Now we have even times even. Well, unfortunately, that doesn't do anything. Then we have even here. That doesn't do anything. So this is going to be what's called the Fourier cosine expansion, because all the cosines are what's going to stay, and all the sines will cancel. Okay, so we're going to solve this one out real quick. So we have a of 0, or a sub 0, which is equal to 1 over pi, right? So this is, again, where t equals 2 pi, so L is equal to pi. Okay, now here's where it's tricky, or, well, it could be tricky. Now, I don't know, personally, off the top of my head, what the integral of absolute value of x is from negative pi to pi. But that's why knowing this is even is really powerful, because the property of even integrals, when you have negative to positive of the same number, is you can take 0 to positive and then put a 2 in front, right? Because if we have this same integral, right, this area is the exact same as this area, so I have 2 times that area. Okay, that's why this works. So now we've made this into something we can deal with, because, well, if we're only in the positive anyways, the absolute value doesn't matter anymore. And so now we just have 2 over pi, x squared over 2, evaluated from 0 to pi. X squared evaluated at 0 is just 0, and then this is pi, so now we have 2 over pi, and then pi squared over 2, which is just pi. Okay, so that worked out really nicely. So a of 0 is pi. Okay, and now we're going to do the slightly more difficult a of n. But we're going to use that same property of even functions. Since we have even times even, it's still even. So we can say that capital A sub n is equal to 1 over pi. And we're going to do 2 here because we're going to cut our bounds. Instead of negative L to L, we're going to do 0 to L. And then we have x, and then cosine of n x dx. Now recall it's n pi x over L, but I already know my L is pi, so the pi's are going to cancel. That's not always the case. It just worked out nicely for these examples. They were designed that way by the professors, and we really thank them for that. So this one, unfortunately, is an integration by parts. You can't do this one directly, so you're going to have to do the integration by parts formula. So you can use your uv minus v du, or you can just use your tabular method like we did last Sunday night. Okie doke. So this is our tabular method. So we've got plus, minus, and plus. And then we're going to use the one that's going to go to 0 as our derivative, and the one that's not as our integral. Okay. Derivative of x is just 1. Derivative of 1 is just 0. The integral of cosine is positive sine. Recall, like we were talking about earlier, you still have to divide by your n, because we're taking the derivative of the inside and dividing by it. So when we go backwards, when we're doing derivatives, it cancels when you get your chain rule. Now we're going to take the integral of sine again, which is going to be negative cosine this time, and that's nx over n squared. Okay, so now we know what our derivative is. So we have a of n is equal to 2 over pi, big bracket, and then we have x and sine over n. So x sine nx divided by n, evaluated from pi to 0. And then we have negative 1 and negative cosine, so it's plus cosine of nx over n squared. Okay, awesome. So now we can move on to evaluation. So we've got 2 over pi still, that doesn't change. And then we already know sine of n pi, or so we know sine of 0 is just 0. So we're going to say this just goes to 0 immediately. Now sine of n pi, every time n is an integer, so sine of 1 pi is 0, Sine of 2 pi is 0, sine of 3 pi is 0, sine of 4 pi is 0. So sine at every integer value of pi is going to be 0. So this whole term goes to 0. Okay, so then we're just left with this cosine term, which is also from 0 to pi. Okay, so cosine of n pi, we already know is that -1 thing. So -1 to the n over n squared. And then we're going to subtract cosine of 0 is just 1, and that's over n squared. Okay, so then we can just do some basic simplification here and take 2 n squared pi, and then that's times -1 to the n minus 1. If you wanted to, you could factor out a negative and make this yeah, you could do something weird with that, but there's really just no reason to. This is a beautifully valid answer. We're just going to leave it like this. Okay, so now we know an is equal to 2 over pi n squared, -1 to the n minus. Okay, so now we're going to plug everything into our Fourier series. So big F is what I use for Fourier, is equal to, now we do have an a of o this time, so now we have pi over 2 plus our summator, n equals 1 to infinity, and we have an a of n, so we have 2 over pi n squared times -1 to the n minus 1 times cosine. We already know that L and pi are going to cancel, so we should have n x, and then plus the bn is 0, so we can just write 0, or we could just not write that at all and call it a day. So this is pretty much the series. We can factor a little bit of stuff out just to make our lives a little easier. So we have pi over 2 plus the 2 and the pi can come out, but that's really it that can come out. Nothing else can really come out. Okay. And again, this does not simplify, this cosine of nx. In order for it to simplify, it would need to be n pi x. So this is as simple as it gets. From here you would take partial sums, and that would be really the only other thing you could do.